So welcome to all of you in video based IT training. In this training I am going to explain you about OSPF, Open Short Test Path first. So what are the different features that make it so popular among another routing protocols? So very first you can say link state protocol. In my previous videos, as I explained you, there are three different categories of dynamic routing protocol. One is the distance vector, one is the link state, and one is the hybrid protocol. So this OSPF comes under the link state protocol. Second feature, open protocol. Allow multi-vendor deployment. It means like EIGRP can be configured only in the Cisco environment where all the devices are of Cisco, but OSPF can be deployed on any vendor, either Cisco or any another vendor devices. So that's why it's most popular as compared to EIGRP, because it is a open standard protocol. Third, default matrices. Matrices means how a routing protocol choose the best path to reach to the destination. What is the basic algorithm behind that to choose the best path? Like RIP use the hop count as a matrices, and EIGRP use the delay, bandwidth, load and reliability. But OSPF use a cost. So what is cost? I will explain in the next slide. So next point is consist of area and autonomous system. In my previous video, introduction to dynamic routing protocol, I have explained you about the autonomous system number. Similarly, OSPF consists of one more term that is known as the area. Because OSPF carries a vast protocol, can be configured on a very big network, large network for the enterprise network. So to minimize the traffic, between the network, so we divide a big network into the small areas. I will explain you about the area also in my next video. Allow scalability. Allow scalability means this one and this point has unlimited hop count. Like RIP can be configured only in the network where maximum 15 router exists from source to destination. It cannot go beyond the 16 hop count or 16 router. Similarly, EIGRP also can be configured maximum up to 255 hop counts, but OSPF have unlimited hop count. It does not have any limit. Unlimited hop count can exist from source to destination, so it can be scalable up to any size of network. Support VLSM and subnetting and CIDR. Like RIP version 1 can only understand class full IP. Means when it is sending the update to the neighbors, it does not send the subnet mask. But when OSPF sending update to its neighbor, it also includes the subnet mask, so it understand VLSM and subnetting and CIDR. So I have already explained you about the point unlimited hop count. Triggered update. If you configure the RIP, it wait for the 30 seconds to send the update to the neighbors. Either there is change in the topology or not, still it keeps sending the update after each 30 seconds. But OSPF does not send the update regularly or some periodic base. As soon as any of the change come into the network, it instantly update to its neighbor. If there is no change in the topology, it will not send any update, but as soon as change come into the network, it send the update to the neighbor instantly. And designed by Discaster. Discaster design the basic algorithm for the link state protocols. So these are the few points for the OSPF. So as I told you, the basic metrics for the OSPF to choose the path is the cost. So what is this cost? How we can calculate this cost? How OSPF calculate this cost? This cost is calculated on the base of bandwidth. So basic formula, 10 raised to power 8 divided by the bandwidth of the link configured or connected. So default bandwidth of the interface. 10 raised to power 8 is considered as the reference bandwidth. Lower the cost, higher will be the better route. As much cost will be lower, that route will be considered as the best route. So cost of a route is cumulative cost for the outgoing interface from this router to the network. What does it mean? Okay, first come to this slide. So these are some default cost or default bandwidth. Like suppose you have a 56 kbps serial link connected from one network to another network, one router to another router, then the cost will be 1785, but it's very slow. No, we are not using 56 kbps link nowadays. We are working on at least 1 Mbps, 10 Mbps and more than that. So like fast Ethernet, by default cost is considered, OSPF consider the 1. I will show you practically this also when we go to the practical scenario. So Cisco router, for the any serial link, by default it consider the bandwidth of 1.544 Mbps. So 10 raised to power 8 divided by, this should be in BPS. So what does it mean? Cumulative cost. For example, what is this cumulative cost? I'm taking this example. Suppose the cost of this link, suppose this is a 1.54 Mbps. So 1.54 Mbps, someone here, it costs the 64. It is a 1.54 Mbps link. By default, because of 5.54, so cost is the 64. So suppose this link and this link. So what will be the total cost? 64 for this point, for this link, and 64 for this. If this particular route network want to send data up to this, then total cost will be 128. And in any case, suppose this cost is 128 and this is also 128. Sorry, my writing is very mistake. I don't have a writing pen. So this cost will be 256 and this is a 128. So router choose this particular path as the best path to reach from this network to this network. Clear? So this is the cost, how the router choose the best path to reach from one source to one destination. And the next point is the hello protocol. OSPF hello protocol. What does it mean? What is the use of hello protocol? Hello protocol is intended to perform the following task. Number 1, dynamic neighbor discovery. What does it mean? Dynamic, like in static routing, administrator manually need to configure the path from any source to any destination. But in the dynamic routing protocol, it automatically keeps searching for the new path. So with the help of hello protocol, OSPF search the new neighbors, detect unreachable neighbor. It automatically detect that particular neighbor is no longer exist in the network down due to any reason. Ensure two-way communication between the neighbors, sending the hello, getting the acknowledgement. means that neighbor is proper condition or not. Ensure correctness of basic parameters, interface parameters. The two interfaces that are connected to know about that particular interface status. And the next slide I will do what are the different parameters that ensure that these particular parameters are correct or not. In the next slide I am going to explain that. Provide necessary information for the election of designated and backup designated router on the LAN segment. Means this new term comes now, designated and backup designated router. I will explain you that also in the next slide, coming slides. So about the hello protocol, if that link is multi-access link or point-to-point link, it send the hello after each 10 seconds. Means just to know that that particular neighbor is working, is in the upstate or not. But if this is the NBMA, non-broadcast multiple access, it is the 30-second timer. Okay. On multi-access or point-to-point link 10 seconds, and non-broadcast multiple access is the 30 seconds. So how it sent the hello packets? Like DR and BDR I have explained you. When DR send the hello to the another protocol, another router in the network, it use the IP multicast IP of 224.0.0.5. But when another router except DR send the hello to DR, they use the IP of 224.0.0.6. So these are the two multicast IP that OSPF used to send the hello packet. So hello interval I explained you, by default at 10 second and 30 second, but we can change it in the later stages by using the command IP OSPF hello interval. That I will show you practically when we come to the practical scenario of that. After the hello, one more timer is the dead interval timer. One of the router keeps sending hello to the neighbor, keep sending hello, but don't get the reply. If it does not get any reply after the 4th time it sends the hello, then this particular neighbor is declared as the down. So router will wait to hear a hello from the neighbor before declaring the neighbor down. So that timer is the by default is the 4th time of the hello interval. So for the point-to-point and multi-point access link like this, it is the 4th time, means 40 second, and non-broadcast multiple access 30 second into 4 is the 120 second is the dead interval. So these are the default, but again we can also change the dead interval of that with the help of this command. Okay, clear? So to become the neighbor, these parameters must match. Hello timer, dead timer, and network type must be identical between the router to get. Means, come back to this particular slide. Suppose on this router, this particular interface connected to this particular interface of the network. Means on both the interface, hello timer, dead interval should be same, network type should be same. Similarly on this particular interface and this particular interface, timer should be same, then they become the neighbor. If it's not matching, parameters are not same, then they never become the neighbor. So it should be identical. So some of the terminology that OSPF use. Very first is the router ID. Router ID means if I want to introduce myself to you, hey, myself Ajay Sharma. In the same way, when router send the hello packet to the neighbor, it also include the neighbor ID. Means router say, hey, my name is XYZ. Now what is this router ID here? The router ID is an identification of the router in the OSPF process. So how the router choose the router ID? By default, it choose the highest IP address of the loopback configured interface in the router. So very first it check if there is loopback interface configured. If yes, then the highest IP of that loopback interface will be the router ID. If we don't configure any of the loopback interface, then OSPF will choose the highest IP address of all active physical interfaces. So very first step, as soon as you configure the OSPF, first it look for any loopback interface. If that is configured, then that will become the router ID. If not, then any of the physical interface, active physical interface. What does it mean, active physical interface? Come back again here. Look here. Like on this particular interface, I have configured the 10 IP series. Okay, sorry, I have configured 10 IP series. So suppose I have configured 10.0.0.1 on this. This interface is configured with 12 interface, and this particular interface is configured with 11. So which one is the highest IP? 12. So what will be the router ID of this particular is 12 IP series will be the router. So next is the neighbor. What are the neighbor? Neighbor are the two or more common router that have a common network, that have an interface on a common network. Means connected to point serial link. Again come back on this. For this particular router, which one is the neighbor which is on the common interface? Like for this particular interface, this will be the neighbor that is connected with this point to point link, and for this side also this will be the neighbor of the router. Okay, so neighbor means directly connected network. Just come back on this. Two router connected on point to point serial link. So that will be the neighbors which are directly connected on point to point link. So next one is the adjacency. In the normal term, adjacency means to maintain the neighborship. Like see here, adjacency is the relationship between the two OSPF router that permit the exchange of routes update. Like in case of RIP, as soon as we configure the RIP protocol, they become the neighbor. But it does not happen in case of OSPF. First it maintains the neighborship, it maintains the adjacency, then it starts sharing the routing information. Like saying is very picky about the sharing the routing information. OSPF directly share the route only with the neighbor that also establish the adjacency. Not all the neighbor will become adjacent. This depend on type of network and configuration of the router. Like in my previous slide I have told you, like this note. To become the neighbor or to maintain the adjacency, these parameters must match on the both end, only then they can become the neighbor. Otherwise, if hello interval is different on both the interface or dead interval is different, network type is different, if you go more advanced, authentication, ID password is not matching, then they will never become the neighbor. So to maintain the efficiency, some of the parameter must match. Next, the hello protocol. I have already explained about the hello protocols. For the dynamic neighbor discovery, keep maintaining the neighborship. These all are the functions of the hello protocol. Hello protocol basically a link state advertisement. It keeps sending the packet that is known as the state of the link state advertisement to build and maintain the topology database. As I've told you, DR sent the hello packet to another router at the frequency of 224.0.0.5. So like RIP, EIGR, RIP only maintain the routing table, but OSPF maintain many more things: neighbor database, topology database. Okay, na? As soon as adjacency get maintained, it send the hello packet. In my next slide I will show you, in my next video I will tell you about the how it become the neighbor, how long process happened to become the neighbor. So when it send the hello packet to the neighbor, the variety of detail including the router ID, when it send the LSA, that I include the router ID and state that are maintained in the, and they become the neighbor. Then the neighbor router start maintaining the database that this particular router is my neighbor, having this particular router ID, this particular IP and other information about the particular neighbor router. So when they become the neighbor, now they start exchanging their routing table with their database with each other. So topology database contain information about all the link state advertisement packet that has been received for an area. Come back to the same. So this router also send the hello packet to this particular router and send to this particular router. This also send this direction and it also acknowledge the it also acknowledge like this. So when all the parameter match, they become the neighbor. So this router, this particular router have two neighbors now, this one and this one, and this particular router is neighbor with this router, and this is also neighbor with this router. In a similar way, it also neighbor this side and it also neighbor with this router is also neighbor with this. Now they start exchanging their database. When they become the neighbor, now they start exchanging their database with each other. Okay, they all start exchanging database with each other. You are my neighbor. Okay, I know about this router, says I know about a 16 network to this router. Now this router also send information that I know something about the 16 network. In the similar way, this router also says to this particular router that I know about 16 network. Now this particular router have two paths to reach from here to here and here to here. So it maintain both the path here. Yes, I know about this router, I know via this path also and via this path also. So it keep all the path in its database. So that is known as the topology table. So topology database contains information from all of the link state advertisement that has received from an area. The router uses the information from the topology database as an input, or in simple way you can say Disgaster algorithm that computes the shortest path to every network, and that best path has been shifted into the routing table. Okay, so there are three databases: neighbor database, directly connected network that become the neighbor, then each neighbor giving some path to the second neighbor router. So it keep maintaining all the database that I have 3 paths to reach that particular network, I have 4 paths to reach that network. So it maintain all the database in its topology database. Out of that, using the Disgaster algorithm, it choose a shortest path to reach to the particular network. So that is the topology database. So I keep saying designated router every time. What is this designated router? In designated router, basically, as soon as you configure OSPF in an area, there is one election process take place. Who will be the master router? Who will be the master router? So, but this particular election take place on the multi-access network, not on point-to-point link. Most common example is the Ethernet LAN connected or non-broadcast multiple access NBMA network. Why this happens? To minimize the number of adjacency. Means, as you know, OSPF is a vast protocol, can have n number of routers, it does not have any limitation. If all the routers start exchanging their database with each other, naturally it becomes the neighbor with 1,000 of the routers, and the database keep increasing one by one. So they choose a DR within a specific area. They choose within a specific area one as the DR. Now which one is the DR? With highest priority. With highest priority or highest, when priority is same, then who won the election? Having the highest router ID. What is the router ID? Highest IP address. So one of the router become DR or the master router in the entire area of the particular OSPF process. So what the DR do? DR, all the routers send their information to DR. They cannot exchange their routing table with each other. All other routers that are not DR and BDR, they can only send the information to DR. Now DR synchronized or make a single make a topology table and send to all other router in the network. So that is the function of DR, to minimize the adjacency and to keep the database synchronized between all other router within the same area. So DR listen and then forward the database. And what is backup designated router? Hot standby designated router. In case of DR goes down due to any reason, instantly BDR, backup designated router, will become the DR, because BDR can listen everything but cannot forward. BDR receive all the update. BDR receive all the updates from the adjacent or neighbor routers, but does not flood or send out the updates to each other. It only send the update when DR become down and this particular BDR promoted as a DR, then it start sending the update to the neighbors also. Okay, so these are some basic definitions. So in my next video I will explain about the different stage of OSPF configuration in single area as well in the multi-area network. So hope you enjoy this video. Subscribe to my channel to get information about new uploaded video on your mail. Thank you.